Hi, my name is Micah Donnelly, and today I'll be talking about what's in the water, and this was for my Chem 120N lab. So, have you ever wondered what is truly in your water? And this can be compared to anything from a lake, a pond, Dasani water that you get from the store, or typically any type of water, even water that you get out of your sink. And what would you do if you knew exactly what was in that water? So, do you need an example? I'll give you one. These people are from Haiti. They get water like this all the time from little creek bays, from any type of water that they can possibly get their hands on. And typically it looks like this. Now, what this water can do is put you in hospitalization. So what I mean by that is you can get any type of disease like cholera. Cholera is a really bad disease that you can get from drinking water like this. This water doesn't contain any nutrients that is helpful for the body. It is only more of a water-based substance that contains soil and possibly even germs and bacteria that can really harm your body and put you into the hospital. So that was just a little beginning, but going straight into my presentation and how that ties in is what I will be talking about is the IR and NMR spectrum of an unknown compound, and that will help give you some type of knowledge on what type of water that you could be drinking and you don't know what could be in it. So, leading into our experiment, our professor gave us an unknown compound. For me, I got unknown compound 61. And leading into this, we were able to use IR and NMR spectrums. Using, for the IR, the Thermo Scientific Nicolette IS5 with OMNIC software. Then, for finding the IMR, or NMR, using PNMR H1 software. So, going to the IR spectrum, in your Chem lab book, it states that the IR is the absorption of a photon in the infrared region, which leads to increase in energy of a molecular vibration. So, what we did is we took two little small salt glasses, and we put 2 drops of our unknown compound onto those and press them together. Then after that, we put them into the IR spectrum, which is shown on the picture. It is a little bit updated from that, but it's very close to what it looks like. And we pushed those in there, and light was transferred through in order to find and give us a graph. And this is basically the key to the graph. So looking at your functional groups, looking at your range of absorption, we can see that if any of the spikes that we have in our graph are shown around these numbers, then we'll know that if it is any type of OH, CH, COO, CCl, or CBr. So, okay, let's go to the IR spectrum then. So we see that the spike is mostly in the 3000 range. Now, if we go back to the last slide that we just had, we can see that around the 3000 area, it would be a functional group of CH. There are no other known spikes that are very shown and very relevant in this case. So we're only going to show the most important, which was around the 3000 range. So then we take it to the NMR spectrum. So according to the Chem 120 lab manual, it states that the NMR is an absorption of a photon in the radio frequency region leads to excitation of the hydrogen nucleus. Now, what we did there is we filled up tubes with our substance or compound, and we stuck them into the NMR spectrum. And what happens is when you drop it in, it closes up and it spins, like shown in the picture. It gives a very good representation of what the NMR spectrum does. Now, what graph we got from the NMR was this. Now, not many people got just one spike out of their NMR, but for me, I did get only one peak. And our ratio from the one peak was a 1:1, so basically it was an NA. Now, looking at all of that together, I was able to gather that the molecule in my unknown compound was benzene because it contained the CH benzene ring. When putting that to actual real life events, it is a potential environmental hazard when it comes to any type of gas or exhaust. That is stated by the CDC. They are very good examples of benzene. But it is a colorless or light yellow type of color. It can create smog in the atmosphere and connect to rain and contaminate water and soil. So it is very important that we don't put benzene out into the air because then it could possibly hurt crops. And off to the side, we look at the picture, and that is exactly what benzene looks like, and that is its structure. So looking at potential health effects, benzene can cause drowsiness, dizziness, headaches, vomiting, tremors, and confusion. We don't want to ingest benzene in any type of form, so it is very important to not. According to the CDC, it works by making your cells not function properly, and that is really big and super helpful for our body to be able to produce cells and have them function properly. So in conclusion, my entire objective out of this entire presentation was to find what was in my unknown substance. And what I found was that it turned out to be benzene. And by using the IR and the NMR spectrums, I was able to find my unknown compound. These are my references throughout the presentation. Thank you.